So today we are going to continue working with the probability of compound events. So we started this yesterday and we focused just on independent events. Now we're going to get into the dependent events. So one more time, just to recap the definitions, a compound event is made up of one or more separate simple events. And to find the probability of a compound event, you need to know if the events are independent or dependent first. So you can decide how you're going to calculate the probability. Remember, independent are two things that are standalone. One does not affect the next event. Dependent event is when the next event is affected by the previous event. So when the first event occurs, the second event is affected by the second event, so the probability changes. So here's a definition. The probability of two dependent events is still equal to the probability of the first event times, so we're still multiplying the probability of the second event after A has occurred. So it's just not P of the second event. You got to make sure you remove what was taken out or changed, whether it was a deck of cards or a bag and whatever else you could have had. So in other words, the result of the second event will change because of what happened first. So let's look at the example of the Best Buy iPods giveaway. So again, we have 4 orange, 5 blue, 6 green, and 5 pink iPods. If Maria and her sister choose one iPod, and it shouldn't be chooses, it should be choose one iPod at random, what is the probability that they will both choose an orange iPod? So we're doing P of orange and P of orange again. This is where we have to make sure that this is a dependent event because they're each grabbing an iPod. It's not like Maria's going to put her iPod back in the bag. They're each going to take one. So in this case, when we figure out our probability, we're going to go P of orange times P of orange, but the second P of orange has a different probability because the bag has a different amount. So at the beginning, there are 20 iPods, and there are only 4 orange ones to pick from. And then we're going to multiply this by the new amount. So once the first iPod has been removed, so here, let's say this is a bag, there's 20 in here, one is removed. So now there are 19 in the bag. So we're going to make sure that our new probability is out of 19. And since we're looking for the probability that the orange one was taken out, there are no longer 4 orange ones in the bag. There are now 3 orange ones if Maria got the orange iPod. So then we're going to go with 3 here. So it's going to be 4/20 times 3 over 19. And then we multiply that. That's going to be 12 divided by 20 times 19. And we multiply 20 times 19, and we're going to get 380. And this will be reduced down by dividing by, we can divide these by, let's see, we can divide these by 4. So we're going to divide here by 4. So I'm going to just write the final answer on the side because I kind of ran out of room. So it equals 3 over 95, which is my final answer. All right, let's go ahead and move on to the next problem. So here we have the letters in the word probability, and they're all placed in a box. If the 2 letters are chosen at random, what is the probability that both letters you're holding in your hand after you remove 2 will both be consonants? So remember, the word consonant means a letter that is not a vowel. So you have to write that down, not the vowels. It's every other letter that is not a vowel. So let's go ahead and figure that out. So we're going to do P of C for consonant times P of C after the first consonant has been removed. So we're going to get P of C. So we look at the word probability. So here it is. We're going to count the consonants. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are a total of 11 letters here. And of the 11 letters, the O is a vowel, the A is a vowel, the I is a vowel, and so is the next I. Let me see, are any other vowels? Just double check. So we have 1, 2, 3, 4 vowels. So 4 of them are vowels, the rest of them are consonants. So again, 4 vowels, which means you would need 7 consonants. So there are 7 consonants in the word probability. So we're going to go 7 out of 11. And we're going to multiply this by pulling out a second consonant. Remember, if we remove one of the consonants, we no longer have 11 in the bag, we now have 10. And we no longer have 7 consonants, we now have 6. And we're going to multiply this, we're going to get 42 out of 110. And we just ask ourselves, what can we divide this by? We can divide these by 2. So when I divide this by 2, I'll just put the answer to the left so you can see it. 42 divided by 2 is 21. 110 divided by 2 is 55. Final answer. This is the probability of getting 2 consonants from the word probability in a row. Let's go ahead and move on to the next one. Next one says you pick a letter from the alphabet. And so you have the entire alphabet A through Z. You pick the letter Q from a bag containing all the letters in the alphabet. You do not put the Q back in the bag, so again, it's dependent. And then you pick another Q from the bag. So let's go ahead and figure out that probability of getting in the Q twice. All right, so in the alphabet, how many letters do we have in the alphabet from A through Z? You should have said 26. There are 26 letters in the alphabet. And in the bag, how many Qs will you have? You'll just have 1 Q in the alphabet. Then you're going to multiply. So after you've taken out 1 letter from the bag, assuming it's a Q, there are now 25 letters in the bag. And how many Qs are left in the bag? So if you took out the Q on the first trial, that means there are no more Qs in the bag. So that means that the probability is 0. You cannot grab 2 Qs from the letters A through Z because there is only 1 Q in the alphabet. So the probability for this one would be 0. Let's move on to our next example. So this one we have a deck of cards. Remember, there are 52 cards in a deck. Just as a reminder. And we are going to figure out what's the probability. We had this problem yesterday, but with replacement, of drawing the heart twice. So what is the probability of drawing the heart twice, or 2 heart cards? So let's go ahead and figure that out. So there are 13 cards with a heart, because there's 13 of each out of 52. So now our deck has 1 card removed, assuming it's a heart. Now we have 51 cards. And of those 13 hearts, if 1 card is removed and it's a heart, we're going to be left with 12 cards. So we're going to go ahead and multiply this out. So let's see what we get. I'm just going to remove this because it's already animated on the next slide, and I don't want to write it out. So we're going to go ahead and multiply the 13 times the 12. I think I may have made a mistake on the previous one. And 52 times 51. We multiply those out. We reduce this. In this case, we are reducing by, let me see, we are reducing by, I believe, 52. And we should get the following numbers. 3 over 51. So again, we divide by 52, and it reduces down to 3 over 51. For cases like this, it actually might be easier to reduce this at the beginning in order to not get such a big number over here. All right, let's go ahead and move on to the next example. And I want you guys to try these out on your own. So go ahead and pause your video and then come back to it once you are done and check your work. All right, now that you've actually checked your work out, let's see if you got these right. So the first one, we have Enrique with tens and ones in his wallet. So he's got the $1 bills, he's got 4, $10 bills, he's got 3. So what's the probability of him getting two $10 bills back to back without replacement? So he's taking one out, has it in his hand, grabs another one. So he's got 2 bills in his hand. So this is dependent because it changes the event on the second try since we've removed one of the bills. So again, there are 3 $10 bills out of 7 for the first trial. On the second trial, there is 1 less bill, so there is 1 less 10. So there are 2 out of 6 left. So we multiply this, and that is a typo right there. Let me fix it. This should be a 6 out of 42. And then we reduce this down. We can divide these by 6. So we're going to get 1 out of 7. So it's a 1 in 7 chance that he's going to grab 2 $10 bills. Let's go ahead and look at number 7 now. We have the 2 jars with the green and purple marbles. So what is the probability of grabbing 2 purple marbles? So we're going to do P of purple times P of purple again. So if we look at our first jar, there are 5 marbles and 2 of them are purple. If we do not put the purple marble back inside, meaning without replacement, so it's dependent, Now we have 4 marbles in the jar, and we only have 1 left. That is purple. So our probability ends up being 2/20, and we can reduce this down. I'll put it up here. Divided by 2, we get 1/10 as our final answer. All right, that's pretty much it. Go ahead and start your practice. Just be careful. The last set of problems is a mix of all types of probability, whether it's simple with just one single fraction or independent, dependent, where you're multiplying the individual probabilities and checking if it stays the same in the total or it changes. So be very careful, read them carefully, decide if it's dependent or independent before you start writing these out. All right, go ahead. Good luck.